Okay, so today we're going to be doing solving absolute value inequalities. Now remember, absolute value is just the difference away from zero or the distance away from zero. So what that means is you're always going to have positive numbers inside here. You can have negative answers for x, which we will. So that's okay, just keep that in mind. Now here, if we look, and you did do this, something similar in Algebra 1, is we have the absolute value of 3x minus 4, closed absolute value plus 5 is less than or equal to 10. This absolute value needs to be by itself, so I'm going to subtract by 5 on both sides, and the reason why I'm subtracting is I'm using the opposite operation, which is subtraction in this case. And then I'm going to have the absolute value of 3x minus 4. And this is less than or equal to, well, 10 minus 5 is 5. Okay, so now since I have the absolute value, and if you remember, we're going to look up here, the absolute value of 4 is 4. Okay, because it's 4 units away from 0. But the absolute value of negative 4 is also 4 because it's 4 units away from 0. Now, because of that, I'm going to split this up. And what I'm going to do is I'm going to draw an arrow here, and I'm going to drop the absolute value, and I'm going to write it the way that I see it. Okay, so 3x plus 4 is less than or equal to 5. And then I'm going to write it a second time, because remember 4 and negative 4 have the same absolute value, and I'm going to have 3x plus 4 is less than or equal to negative 5. So I have two separate problems here, and I'm going to draw a line through the inequalities. And then I'm going to solve for these separately, okay? They are two separate problems. So this 3x plus 4 is less than or equal to 5. Pretend that less than or equal to is an equal sign, and you solve it the same way. So the opposite of, ooh, this should be minus 4, sorry. I don't know why I changed it to plus 4. Okay, minus 4. The opposite of minus 4 is plus 4, so add 4 to both sides. Cancel out here. 3x is less than or equal to 9. Divide by 3, divide by 3. And I'm going to write it over here. X is less than or equal to 3. Okay, so that's just solving. You use the opposite operation and you solve it, okay? We did solving equations earlier. You guys should be able to solve that pretty quickly. Same thing here is I have 3x minus 4 is less than or equal to negative 5. So I'm going to add 4 to both sides. They're going to cancel out over here. Add 4 over here. 3x is less than or equal to negative 5 plus 4 is going to give me negative 1. Divide by 3, divide by 3. And I'm going to write it over here. X is less than or equal to negative 1/3. You can get a negative for your answer. That is okay. That is acceptable. Okay? We do expect you to get it. The only time that it's going to change is if I say, what's the absolute value of negative 4? Well, it's 4 because it's 4 units away. What's the absolute value of negative 1/3? Is 1/3. Now, if we look at this, because this original problem is less than, I'm going to have an and statement. So what that means is I'm going to look at these two numbers. I have negative 1/3 and 3. And I'm going to say which one is smaller. Well, it's obviously negative 1/3. Okay, we can visually see that. And then 3 is bigger. So I'm going to have an x in the middle. And then I'm going to use, because it's less than or equal to, less than or equal to, less than or equal to. So basically what this is saying is negative 1/3 is less than or equal to x, and x is less than or equal to 3. If we were to graph it on a number line, looks like this. I'm going to graph negative 1/3, 3, and I'm going to pick 0 in the middle. The reason why I'm picking 0 in the middle is if I put 0 in here, negative 1/3 is less than 0. Yep. 0 is less than or equal to 3. Yeah, that works. Now, because it's less than or equal to, that equal to means we have a closed circle right here. Closed circle. Closed. And then the 3, because we have less than or equal to, that also means we have a closed circle. And we already checked 0 does work, so you shade in the middle. And we'll go over shading in the second problem as well. Okay? And I did link my absolute value video for Algebra 1, so you guys can double check that and you can look at the signs and stuff. So let's do example 2. So we have 2, absolute value of x plus 7 is greater than 8. I need that absolute value by itself. So that 2 is actually being multiplied. So I'm going to divide by 2 right off the bat. Okay, the 2's cancel out right here. And I have the absolute value of x plus 7 is greater than 4. Here's where you split it up. So I'm going to have, you're going to drop that absolute value. X plus 7 is greater than 4, and x plus 7 is greater than negative 4. Or I'm sorry, this should be less than. Is less than. Because we have the greater sign, we're going to flip the other one. And now I'm going to solve for this. And this is actually really nice. Because I have x plus 7, well, I'm just going to subtract by 7 on both sides. X is greater than negative 3. Same thing, subtract by 7, subtract by 7. X is less than 11. So because we have the greater than sign, you do have to flip one of these. And this is actually going to be an OR problem, so I would leave this as my answer. I would say, well, x is greater than negative 3 or x is less than negative 11. If you graph this on a number line, and I'm going to have negative 11, negative 3, and I'm just putting 0, so I have another one. At negative 11, because it's less than, it's going to be open. At negative 3, because it's greater than, it's going to be open. And now if I look to see where I shade, well, I want to shade anything less than. So negative 12 is less than negative 11. Yeah, that's right. So I shade this way. And then this one, I'm shading anything greater than. So I'm just picking 0 because this one's the easiest. 0 is greater than negative 3. 100%. So you shade this way. Okay. Let's go to our last example. Example 3. Now for this one is we have 3 absolute value x plus 2 minus 6 is less than or equal to 9, which means that the signs stay the same. We don't have to flip anything. That's super nice. Well, the absolute value isn't by itself. I have a 3 and I have a negative 6, so I'm going to add 6 to both sides. So I'm going to have 3 absolute value x plus 2 less than or equal to 9 plus 6 is 15. Then absolute value is still not by itself. This 3 in the absolute value right here is actually being multiplied, so I'm going to divide by 3, divide by 3. X plus 2 is less than or equal to 5. Well, now this is, the absolute value is by itself, so I'm going to break it down. So I'm going to have x plus 2 less than or equal to 5. X plus 2 less than or equal to negative 5. I know this one's kind of off. There we go. And before I start solving, draw my lines. Now this is a simple equation to solve, or an inequality, because I'm just subtracting by 2 on both sides, because the opposite operation of addition is subtraction. So minus 2, x is less than or equal to 3. X is less than or equal to, if we subtract, remember they cancel out here, negative 7. And because this is a less than, this is an and statement, so I'm going to look 3 and negative 7. Which one of these is smaller? Well, it's negative 7. So negative 7, then 3. Remember, x goes in the middle. And because it's less than or equal to, you just have less than or equal to and less than or equal to. So if we were to graph this on a number line, I'm going to have negative 7, 3. I always pick 0 because it's just a nice number. It's less than or equal to, so the equal to means that it's closed circle. Same thing with 3, closed circle. And then does 0 work? I'm just going to plug it in, substitute it in. Negative 7 is less than or equal to 0. Yep. 0 is less than or equal to 3. Yep. So you shade in the middle. Okay, so for a recap, I'm actually going to go over example 2 because I think that one's the hardest one out of all of them. So for example 2, for our recap, get the absolute value by itself. Let's cover this one up. Oops, sorry guys, there's a lot going on. Get the absolute value by itself, whether it's multiplying, dividing, addition, or subtraction. Get it by itself and then split it up. Once it's by itself, split it up into 2 parts. Now, because this is greater than, we have to change this one to less than. So 1 greater than, 1 less than. The less one goes with a negative sign. So the first one, you write it the exact same way. You do not change anything. So x plus 7 is greater than 4. The second time you write it, because it is a greater than, if it was greater than or equal to, you also would flip it. You're going to have x plus 7 is less than negative 4. At this point, you solve for both of these. Now, this is really nice because it's plus 7, so you subtract 7 on both sides. Because it's greater than, this is going to be an or statement. So I have x is greater than negative 3 or x is less than negative 11. Here's where you graph it. Because it's greater than and less than, they are both open. Open. If it was greater than or equal to and less than or equal to, they would be closed. But because it's less than or greater than, open. And then you just test it. So here I said, is negative 12 less than negative 11? Yep, so you shade where it's true. You shade where it's true. Here, negative 3. I picked 0 because 0 is the easiest to see. Is 0 greater than negative 3? 100%, so you shade this way. You shade where it's true. Okay? Again, you shade where it's true.